Good morning, everyone. We are Team Soul Society and we built BlockOps. BlockOps is our no-code AI agent platform for on-chain actions and consumer DeFi. The idea is simple. You tell the agent what you want in plain English or build it visually, and BlockOps takes care of the planning, execution, verification, identity, and audit trail behind the scenes. Lit protocol enables two secure wallet modes. First, PKP wallet mode. A programmable key pair is minted on Lit, with no private key ever exposed or stored. Transactions are signed directly through Lit's decentralized network, creating a completely seedless and secure wallet. Second, traditional wallet mode. Users can import a standard private key which is encrypted using Lit actions and stored securely. Decryption also happens via Lit actions, only at the moment of signing, so PKP mode is fully decentralized and keyless, while traditional mode stays compatible, but encrypted and secure. Right now, we will use traditional wallet mode. There are really two ways to use BlockOps. You can build an agent visually with drag and drop tools, or you can just talk to it in chat. Either way, it runs on the same backend runtime, so what you're seeing isn't just a UI trick. The agent is actually planning actions, calling tools, verifying results, and logging what happened. Flowchain is where the consumer DeFi side of BlockOps shows up most clearly. Instead of asking users to figure out gas, RPC endpoints, bridging steps, or wallet setup on their own, BlockOps lets them start with simple intent. They can ask how Flow is configured in the app, check whether their wallet is actually ready to use, and then move straight into actions like recurring savings or scheduled payouts. That is a very different user experience from the usual crypto flow of switching dashboards, copying addresses, and manually repeating the same transaction every week or every month. What we wanted here was a version of DeFi that feels understandable and routine. Savings, payouts, grants, and payroll should feel like something a normal user can set up and trust, not something only a power user can operate. A prompt like pay 10 flow to this address on the first day of every month is exactly the kind of behavior we want to normalize. Flow is a strong fit for that because it lets us frame blockchain finance as a consumer product instead of a developer workflow. Under the hood, this is where the agent part really matters. BlockOps takes the user's intent, figures out the right steps, uses the right tools, checks the outcome, and returns a structured result. So it's not just replying with text, it's acting more like an operator that can actually do work while still staying within clear guardrails. Another important part of the system is identity. In BlockOps, an agent doesn't have to stay as a row in an app database. It can be registered on-chain through ERC 8004, linked to an operator wallet, exposed through a public manifest, and discovered through the marketplace. That matters because once agents start acting more independently, identity cannot just live inside one product UI. We wanted every agent to have a verifiable reference point outside the app itself. The ERC 8004 layer gives us a way to tie together who the agent is, who operates it, what capabilities it exposes, and what trust context should travel with it. So instead of a profile that only makes sense inside BlockOps, the runtime can point to something machine-readable and externally verifiable. That makes the agent easier to discover, easier to reason about, and much easier to integrate into trust-based systems where identity, reputation, and validation actually matter. We also wanted the system to leave behind real receipts. After tool execution, BlockOps builds structured audit records containing the tool call, sanitized parameters, execution result, chain context, and storage metadata. Those records can then be archived to Filecoin calibration through Synapse SDK, which gives us a CID-backed audit layer outside the app database. That means the proof of what happened is durable and portable. It is not just a message in the chat window, and it is not just a row hidden somewhere in the backend. If someone wants to inspect what the agent did, what tool it called, what inputs were used, and what came back, there is a concrete audit trail for that. For us, that is a big part of making autonomous systems feel accountable instead of opaque. BlockOps is built to work across multiple real interfaces. Agents can be called through APIs and accessed through Telegram. Telegram messages are routed into the same BlockOps chat pipeline, so Telegram can reuse the same tool execution, conversation handling, and verification flow as the web app. A user can also connect a specific agent through its agent ID and API key, so the bot can operate with that agent's configuration instead of only running in a generic mode. The bigger point is that web chat, API calls, and messaging interfaces all plug into the same execution runtime. That makes the platform easier to extend, because a new surface does not require us to rebuild the agent runtime from scratch. Thank you. We are Team Soul Society.